So this is the step 2 explanation of the Web API project. As I already told you, this whole project controlling electrical switches has three projects. First is Web API, second is WinForm, third is ESP32. In this tutorial, I will be explaining about the ASP.NET Core Web API project. And let's straightway, first of all, let's have a review of what we talked in the previous tutorial. I'll show all the web API requests that are taking place. So once these are in place, I will be explaining about all of them. As I told you in the first step, this is the request that goes your ESP32 device. It makes a GET request to your ASP.NET Core API, and after that a series of web requests take place. We will cover all of them one by one. Today we will be concentrating on this part. This is the part that is communicating through all these web API endpoints. Let me now open the Visual Studio project that I have created. This is the project that you can see from your downloads, and since this is an entirely a web API project, we do not have any razor pages included. The only thing we have is an app_data folder to hold our data and model classes, and obviously these handlers for JWT based authentication. So let me start with app_data first. In this I have a JSON file. This JSON file hardcodes the user ID and password. This will be coming from the console application from the C# console, from the C# WinForm application, or from any client. We have hard-coded user ID and password so that we do not have to go through a longer or other process. We can always maintain these in a JSON file on the server. So that is why I have written here, because these are not very critical. If it is critical, then these can be stored in environment settings, or maybe a formal identity based authentication can be made, or some sort of database arrangement can be made. But for the current project I have hard coded them. Then we have model classes. Let us quickly have a look at the model classes. This is the model class ESP32 device. It has a property for Wi-Fi MAC address of the remote device and the current IP address of the remote device, because we have to make a to and fro communication with the remote device. So we have to store its IP address and MAC address. Then we have a property for we have a model class called switch. Let me fold it away to explain the various properties. This switch class has a property called ID. This is a unique ID of the switch. Now what is this switch? As I will show you here, this switch represents one of the LEDs that are glowing. So these are GPIO ports. Each port is a binary bit. So 0x1, 0x2, 0x4. Whenever this API application sends the state of the switches, it sends a 1 int number. This number is then made a bitwise check. If the first bit is set, this will be altered. If the second bit is set, this is glowing. If the third bit is set, this is glowing. You have a binary story. So this is the bit for your this switch. This bit will be for this switch, and similarly 100 will be for this one. A sort of a binary bitwise test is made on the ESP32 program. So that is why we have a property called bit. This bit is either 1, 10 or 100. So it is that way that this will store, and this is on. It stores the current state, and this foreign key, it stores the MAC address, the ESP32 device on which this bit is located. You can have many ESP32 devices on your network, so that is why this is a foreign key, and these are the bits for this. And in fact I am using only 3 bits, but ESP32 provides many bits that can be done. So accordingly, this project is capable of handling many switches. So after this switch, let us come to the project context. It is quite simple. It stores a DB set for devices for switches, and the data source, the connection string for SQLite, is set as app_data. Database.db is the file that will store our databases. And now let me come to the program.cs file. These are the packages you must install: SQLite, tools, JWT bearer, because we shall be using JWT authentication, and I will come to that in a moment, but let me first start explaining the program.cs file quickly. This is the usual boilerplate code: create builder, the environment is set as development, you can change it according to your needs. There is a port. Now because the devices have to communicate outside of the single PC, we need to open a port for communication. There is a video that I will attach that explains how to open this port on your PC, on your Windows computer. And this part, this calculates the current IP address of the machine, and accordingly the URLs are set as localhost or LAN IP, whatever is your LAN IP. It should be usually fixed from your router. Depending on what is the series available, you can fix this port on your router. There are suitable settings that are allowed. You will have to check the documentation, and you will have to set this port, fix this port, so that your ASP.NET Core application, it runs on this fixed IP address. And as I have told, this is the port, so any communication will take place on this IP address and this port. So this is the first part that is important. And after this we have to make and then we have added this project context, and then we have to make arrangements for JWT authentication. And let me just show where we are going to use it. This JWT authentication will be done between the WinForms application and your web API. In the first step, your WinForms application will send a GET request to your API, and it will send a JWT token, and in this GET request it will send the user ID and password. These will be checked on the server, hard-coded values, they will be checked, and a token will be sent. In every future communication, these user ID and password will not be sent, this token will be sent. This is all about JWT authentication, the basic theory. And now let me come back to the project, so that we can have a look at the JWT configuration. Again, as I tell, this is mostly a boilerplate code that you can always copy paste in your projects. A simple system is there. Define a string called basic, a client secret key. This can be stored anywhere safely. I put it hard coded here. This has to be any 16 Unicode characters or more, must be greater than 16 Unicode characters. And a JWT params variable will be used later in the next code below. And token validation parameters, issuer signing key, and your domain name, and some sort of your endpoint. You can keep it like this also, it doesn't really matter much in this project. And you can read the documentation to see what all this actually means. I have set some dummy values here. And once my JWT params are there, I will use them in my this configuration. This is add authentication middleware, add scheme, the basic scheme that I have defined above, the variable, the constant variable, and this is JWT bearer, and this is where these params are used. This is again a boilerplate code that can be copy pasted, and I have done exactly the same thing. I haven't applied any mind here. I have just copied it, obtained it from the MSDN documentation, and it serves my purpose always. And after this, add authorization build, This is a logger that tells environment is this, listening on this, so that your console window that opens for Kestrel, it can show you the port. Also listening on localhost. HTTP secure is not supported, use HTTP. And after this, we are not supporting HTTPS because of certificates on local communication, which might be a bit of problem. But once this project is done for a hosting commercial use, then you can use HTTPS also, and it will be in fact quite easy on that, because most of the things are done for you by your host. Then we have a project context and get any pending migrations, because we will be using migrations, and once the migrations are applied, your database will be created. And if you still cannot connect, we will say, have you applied migrations? So this is basically a safety check whether our database connectivity is okay or not, and I'll show you in a moment how this is actually going to work. And then we have this use authentication, use authorization as usual. And now comes our first GET request. This remote ESP32 sends this call to give its MAC address and IP address, and it is at this point that we are at the moment. So what do we get? These parameter is the MAC address that will be sent, and this is the project context, dependency, HTTP context, web host environment dependency injection. And here we have to send the state, so we have an int variable. This stores the IP address, and this is the ESP device found from the database. If the device is not there, then we add a device and add 3 switches with a bit value of 1, 10 and 100. These bits are understood by the ESP32 part, and I will show you there how we have used it. And the default state we set to false and set the MAC address to each of the switches, and this MAC address will allow us to send the MAC address to the remote ESP32, so that it can know that this is coming from a valid caller. I think I need a little explanation here. This ESP32 knows its MAC address. It sends its MAC address here. This MAC address is registered. So whenever this put request is coming from this server, this MAC address is sent, so that this device can validate that it is its own request that is coming. And now let us come back to the API that we were discussing. Then it is added to the database, else we will query the switches and run a for each loop on all the switch to create a bitwise of all the bits which are active. So if your first bit only is active, you will be sending a number, this one. If your second switch is also active, then it will become 11, so the number that will go will 3. And if third one is also active, then the number will go as 5. So these are decoded on the remote machine. You can take some time to study this and convince yourself. And here we are storing the IP address into your device, and we are saving the changes. So our device now, this ASP.NET has the MAC and the IP address in its devices table, and in the switches table it has 3 switches, and it has sent the current state to the remote device. Ret state it has sent. After this, our next web API is the GET request that comes from the WinForm application. It asks for token, and here it says authorization scheme is basic, and for this basic scheme, if we go back, it is here that we describe the handler for this. In this handler, we will be checking if the caller is authenticated, and let us have a look at that. This is again boilerplate basic auth handler, authentication handler, inheritance, and handle authenticate async. The header is parsed and user ID and password are extracted from the header that is coming, and the path to the JSON file for comparing if they are equal. If everything is equal, we send a success authentication ticket is automatically created for us by the APIs of ASP.NET Core. Otherwise, a failure message is sent. So once you succeed here in this, once you succeed, you create a JWT token and send that token in an access underscore token JSON variable to your remote caller. In the remote caller, this access underscore token that will be coming from this server, this will be cached, will be stored somewhere for later requests. Our next API is getState. This API request is made by the remote client so that it can adjust these display, and for this we have just folded it in single line JWT authentication, and this is switches to array. So this will send all the switch states in one array. So this is switch, this whole table in a way will go to the remote, because a remote WinForm application might be controlling many Mac devices. So it sends effectively the whole table to your caller. The whole table of switches is sent in the form of an array, JSON array, and it will be decoded there, and display will be created out of this JSON. And once it decodes this array, this state is set. So this part is over, this is over, this is over. Now when a user clicks here, it will send a put request on set state. It will send the switch ID, the ID of the switch to turn it on. And let us now have a look at here also. So this is coming from the remote, and what is done here, let's have a look at that. The first thing it does is that on the basis of the ID sent by the remote caller, we query for the switch, and here what we are doing is we are also extracting the associated foreign key data, because this is the way for getting the data of the associated device. Here if you see, we have a foreign key. This whole data has to be extracted from the ESP32 device table, because we need MAC address and IP address. So it is this EF core trick load async will help us get that data. So at this point we have the switch and the related data, and now we are collecting the current state of the switches. This is obtained by creating a bitwise OR, as I already explained above also, and then this particular bit is toggled. This bit is sent by the remote caller. It is saying turn on, and from the switch ID we obtained the actual bit of the device, and now the state, that particular bit is being toggled. And once we have the bit state, the new bit state, we will send it to this. Here it is received, and now it is further sending a put request to the remote MAC address, and let's have a look at that also. For sending the further request, we create an HTTP client, and this is the JSON that we have to send. This will be extracted by the remote ESP32 device. For a new person, this might be a bit confusing, but it's not that difficult if you are a little bit conversant. In fact, this is now created as application JSON. The content, this will serialize your MAC and state, and this is put async. This goes to the remote device HTTP by IP address of the listener, and this JSON, it goes to the remote device, and if some error we say not found, because sometimes the device is not active or booted. In that case these error checks are there, and if everything succeeds, if the remote device it responds correctly, then if it responds okay, then we send this verify and wait. If something wrong occurs, then we say not found. If it sends a okay response, in that case we read the response string, and if the response string is okay, this will be sent by ESP32. We turn on our device and save the changes so that the database is updated, and we send no content because content doesn't make any uh, meaning in this case. And otherwise, if something goes wrong, we say not found, and this is the last app dot run. You will have to spend some time to understand this whole code. It's not difficult. So if you sit patiently, then you can understand this entire code. I'll close it right now, and in the next tutorial, wait, let me first make a run of this so that you can see how it will actually run. So when you run the first time, it will say fail, have you applied migration? It is this migration that I must apply so that my database is created. Otherwise you can see it is running on this port 192.168 whatever. And now I will open this package manager console, and I will apply initial create and hit my enter key, and if everything goes okay, I will succeed, and I can have a look at if I refresh this, my this will be created here, or I will have to run it the first time once again to see them created. And let's wait for that to happen. And now it is all migrations applied, and here you can see my database is also created. I will stop this and you can test it on your own. I'll close it right now. Thank you.